Welcome and hello. This is a support video in HEC RAS, and in this video I'm going to be talking about cascading dam breaches. This is a situation where there's two dams or two reservoirs in series, one's upstream of the other, and if they both breach, how to make something like that happen in HEC RAS. So what I have on the screen here is my HEC RAS, and what I've done is created a similar situation to what was asked. In case of cascade dam, how do you make the simulation work? All right, so upstream, what I have is a storage area right here. And then I have an SA2D connection right here, which is serving as my dam. And then I have breach data associated with that connection, which we'll check out in the geometric data editor. So this is the upstream dam right here. This is my 2D flow area downstream of that upstream dam. And then if I just scroll down to the downstream dam, I'll call this dam 2. This one's dam 1. What I have is a 2D flow area that's connected to another downstream 2D flow area. So even though the term is sometimes SA to 2D connection, you can also connect two 2D flow areas together using this SA 2D connection element. All right. So if I toggle on the terrain, you can see that I've got everything geo-referenced. I've got a land cover layer. I've got my break lines and my 2D flow areas. Everything is set up and ready for a simulation. Before we do that, I just wanted to show what my geometric data editor looks like. So here is the geometric data editor. I'm going to, first of all, zoom in on the upstream end. This is the upstream dam and my storage area. Here is the storage area data. Okay. If I look at this dam 2 right here, I'll click on SA/2D connection. That's dam 1. Here's the dam 2 geometry. So I'll pull that off to the side here. Here is the weir embankment data. So it has a top elevation of 800. Here, I'll pull that off to the side. That's this little weir right here. And I also have some dam breach data. So if I click on breach right here, here is the breach data. What I'm saying is it takes 1 hour to breach. The breach begins when the water surface elevation hits 780. The breach is centered at 725. The bottom width is 100 feet, and the final bottom elevation is down here at 460. Okay, so you can see that by the red outline. It is a linear breach progression, just 0 to 1 right there. I'm actually going to toggle off the breach first and then save the geometry. We'll run the simulation without a breach, and then we'll return and run it with a breach. So click OK. We can close that. We can close that. We'll go File and Save Geometry. All right, let's check out some hydraulic data. This is the unsteady flow data. My boundary conditions on the downstream end is just normal depth of 1%. And then the storage area also has a boundary condition, which uses lateral inflow. So I'm just basically saying we have a constant 20,000 CFS flowing into that storage area 1 at the very upstream end of our model. So if I click OK, then click off, let's close that as well. I'm going to File, save the geometry data. Let's go ahead and run this now. So I'm going to go up to Run, Unsteady Flow Analysis. What I have set up here is a 5-day simulation. So it's going to go from January 1 to January 6. We have two storage area connections with breach data, but neither of them are set to breach. So this should not take too long. I'll go ahead and click on Compute and let that run. All right, that finished. Go ahead and click on Close. Let's take a look at some of those results, but in RAS Mapper. So opening up RAS Mapper, here I have results base, that's the name of my geometry, and here is the depth. Let's go ahead and check out the depth versus time. So it's starting with the storage area. I'm just going to go right click. I'm just going to click right click, plot time series, and then depth. So we can see that over the course of the 5-day simulation, the water surface increases from 238 and then it ends at up at 250. Okay. So we should have some flow down here, just downstream of the upstream dam. Right here, it looks like the water starts to spill through that spillway right here about 6 hours into the first day. And then the depth just continues over the course of that 5-day simulation. If I take a look at that same depth versus time plot, but further downstream, just upstream of my downstream dam, I'm calling this dam 1. Let's just do a right click and then check out the depth versus time plot. Okay, now it looks like it takes a day and a half, a little bit more, for the water to actually appear. And then I'm not sure what's happening here, but it looks like the depth ends up being around 6 or 8 feet by the end of the simulation. I probably should have used a warm-up period or even one of the advanced time controls. Or perhaps if I went to computation options and tolerances and used the advanced time control for Courant number, I'm going to go ahead and leave that on with these settings for the simulation that involves a breach, because otherwise I'm probably going to get instability. So I'll click OK. I'm not going to run that quite yet. I will save it though. And then let's take a look at the animation of that last model run. So let me scroll upstream here. I can toggle off the terrain, toggle it on. What do you guys think? I also have a couple other land use. No, how about Google imagery? Okay, that looks cool. Let's give that a shot. So I'm going to click the play button. And after 6 hours, it's 3, 4, 5. There we go. So the water is slowly making its way downstream. If I zoom out, we should follow that water. Kind of hard to see it. In fact, let me toggle off the Google satellite. Here it is, making its way. It's approaching the lower dam here. Okay, so we're about 3 days, almost 3 days into the simulation. Okay, and there we go. Just like that, the water has now exceeded the weir invert of the downstream dam, and now it's starting to gain depth downstream as well. All right, so I'm going to go ahead and stop that. Let's go ahead and breach the dam. So I'm going to go to the geometric data editor, edit geometric data. And then for my SA 2D connection, I'm going to select dam 2. That's my upstream dam. Click on breach plan data. Click on the checkbox to breach this structure. Okay. Close that, close file, save the geometry. Now I'm going to run unsteady flow analysis. Now it says that 2 storage areas have breach data. One of them is set to breach. That's the upstream dam. And the time step is using that current condition. All right. So this may take a while, but I'm going to go ahead and click compute. All right, that simulation ended. It took about 45 minutes. I'm going to go ahead and click close. Close that. Let's take a look at some of our results. So let's go back to RAS Mapper. All right, that opened up. I'm going to zoom out now and toggle on my results, specifically the base geometry, and let's take a look at the depth. So I'll select the depth field and then roll back the simulation to the start time. All right, I have the entire map in the view right now. Right up here at the top is the storage area. Here's dam 2, that's our upstream dam, and then reach 2 down to dam 1, and then reach 1 downstream of that. Zooming in on the storage area, I'm just going to go ahead and check out the depth parameters. So that's calculating. That makes sense. It looks like the breach occurs just at this time right here, which is about 6 hours into the first day. And then the elevation drops into the bottom of the breach invert. Downstream of dam 2, if I take a look at the depth, we would expect a huge inflow or influx right here where we have 0 depth and then it goes up to 160 and then back down to 150. Let's check out a spot further downstream. So just upstream of dam 2, the downstream dam, I'm going to take a look at the depth right here. Looks like a similar plot. So let's go ahead and run the simulation now. I'm going to go ahead and click the play button right now. See, that's 2 hours, 3 hours, 4 hours, any moment now. There it goes. There's the dam breach. So we're just still at the very end of day 1 now. It looks like the breach took place and instantly flowed down to the downstream end of our second 2D flow area. All right, well, that was it for this support video where we talked about how to create 2 different dam breaches in series using a 2D flow area, 2 2D flow areas, and then upstream of both dams was a storage area.